Hey everyone, and welcome back. Today, we're going to pull back the curtain on one of the most fundamental ideas in AI, parameters. These are the little numbers that literally define how a model thinks. And honestly, if you want to get AI, you've got to get this. So let's just dive right in. What exactly are learnable parameters? I mean, you hear this term thrown around all the time, right? People talk about how big an AI model is, how complex it is, but what are they actually talking about? Well, it's pretty much what it sounds like. A learnable parameter is just a value that the network, learns while it's training. You can think of them as the AI's internal memory or its knowledge. We're talking about things like weights and biases, and these get tweaked over and over and over again through trial and error. It's basically the knobs and dials the AI tunes to get smarter and more accurate. Okay, so how do we figure out just how many of these parameters are packed into a network? You might be thinking this is going to involve some crazy high-level math, but you'd be wrong. It's actually surprisingly simple. Let's break down the formula for figuring out a model's complexity. It really boils down to just two simple steps. First, we figure out the number of parameters for each individual layer, and then we just add them all up to get the grand total for the whole network. That's it. Simple as that. And here it is, the key formula we're going to use. For a standard, what they call a fully connected layer, and that just means every little node is connected to every node in the next layer. The math is super easy. It's just number of inputs times the number of outputs, plus the biases. And here's a little pro tip. Number of outputs is really just a fancy way of saying the number of nodes in that specific layer. Easy, right? All right, theory is one thing, but let's actually make this real. The best way to get a feel for the anatomy of a network is to just walk through an example and put our new formula to the test. Let's do it. So here's the little network we're going to work with. It's a simple, fully connected model. We've got an input layer with 2 nodes, then a hidden layer with 3 nodes, and finally, an output layer with 2 nodes. Now, here's a really important thing to remember. The input layer itself doesn't have any learnable parameters. None. It's just the front door where the data comes in. All the real learning happens in the layers that come after it. Okay, let's get our hands dirty. We'll kick things off with step 1, calculating the parameters for that hidden layer. Right, so this hidden layer is getting its information from the input layer, which we said has 2 nodes. So that gives us our first number, 2 inputs. And the number of outputs? Well, that's just the number of nodes in this hidden layer itself. And we know that's 3. Now we just plug those into our formula. We multiply the 2 inputs by the 3 outputs, which gives us a total of 6 weights connecting these 2 layers. But wait, we're not done yet. We can't forget about the biases. See, each of those 3 nodes in the hidden layer has its own bias term, so we've got to add 3 to our count. And there we go. 6 weights plus 3 biases. That gives us a subtotal of 9 learnable parameters for our hidden layer. First part, done. Awesome. Now let's move on to the next layer and see how this all stacks up. Time for step 2, the output layer. And you'll see the process is exactly the same, so this should feel pretty familiar. Okay, so what are the inputs for this final layer? Well, there are the outputs from the layer right before it, the hidden layer, and that layer had 3 nodes. So we've got 3 inputs. And the number of outputs? Our final layer has 2 nodes, so that means we have 2 outputs. Simple enough? Let's run the formula one more time. 3 inputs multiplied by 2 outputs, and that gives us another 6 weights. And finally, we add the biases. Since this output layer has 2 nodes, that means we've got 2 bias terms to add to the pile. And that gives us our second subtotal. 6 weights plus 2 biases equals 8 learnable parameters for the output layer. Almost there. Okay, we've done all the heavy lifting. We figured out the parameters for each of our learning layers. Now it's time to put it all together and get that grand total. So we just add the 9 parameters from our hidden layer to the 8 from our output layer, and that gives us our grand total, 17 total learnable parameters. These 17 little numbers are what our network is going to tweak and optimize as it learns from all the data we feed it. Okay, so we can do the math, that's great. But why does this number actually matter? Let's zoom out a bit from the calculation and talk about what this parameter count really means in the grand scheme of things. This number is so important because it's a direct measure of a model's complexity, its potential to learn. The more parameters you have, the more intricate and complex the patterns are that the model can learn from data. It's kind of like the model's brain capacity.
These are the values that get fine-tuned during training, and honestly, understanding this simple calculation is the first step to wrapping your head around much, much bigger networks.
So let's end with this thought. Our tiny, simple little network has just 17 parameters. Now think about the AI you use every single day, the one that recommends your next video or translates a conversation in real time. How many parameters do you think those have? We're talking hundreds of millions, sometimes even billions. It's just staggering to think about, right? And it all starts with the simple math we just did today.